Hey guys, let's get started. Even though I'm not there today, we're still going to do our normal process, starting with warm-up and planners, and then we'll do notes. So if you haven't already grabbed your binder, do that and open up to your notes your warm-up section. So green warm-up paper. We are on Tuesday, and today's date is the 4th, so that's 10/4/22. Only 2 warm-up questions. I just want you to evaluate the 2 multiplication problems. Evaluate just means solve, so do the math. It should not take you more than a few seconds to, hopefully, maybe at least a minute, to do the first 2 questions. It's okay if you don't want to write down the questions. You might be able to just do them in your head, but please write down your answers. Question 1 that you're solving is just 3 times 3. And question 2 that you're solving is 2 times 2 times 2. Please note that is this 2 over here that I'm kind of putting a little squiggly wiggle around. That is the question, not part of the answer. So pause your video, attempt the question, and unpause to check your work. Okay, hopefully this wasn't too bad for a Tuesday morning. Or Tuesday afternoon, I guess. Number 1, 3 times 3, you should have gotten 9. And number 2, 2 times 2 times 2. If just in case this gave you any trouble, my best recommendation is when working with multiple numbers being multiplied together, just group them together. Do 2 numbers at a time. 2 times 2 would have been 4, and then you bring down what's left, times 2, and then you can group these 2 together, which gets you 8. Planners. Let's open up your planners. I am doing a planner check tomorrow, so please make sure you have this written. It says, Lesson 9 homework on Schoology. I know you had homework yesterday. Yes, you're going to have homework again today. This week, as I told you yesterday, is a busy week. You guys have a lot of homework this week. It'll be the most homework you've had all year, all in 1 week. So please make sure you're staying on top of it. But tonight, you're working on Lesson 9 homework on Schoology. Here's our agenda since I am not here today. Warm-up, check. Planner should already be written. After this, we're going to jump to our notes. Then you're going to work on homework and Dreambox. Please remember that from yesterday, you only have 3 Dreambox lessons I'm asking for this week, just because you have a lot of other homework. If you're going to do the 4-box notes, then you can start to get that piece of paper ready now. I am going to pause the video to jump over to our notes. Okay, here we go. So if you're using the 4 boxes, then you can fold your piece of paper into 4s. If not, that's okay, but you still have to write down all of the same information that I am writing down on my screen. Let's start with your title. Your title across the top of your piece of paper should say Lesson 9, Exponential Expressions. It's a big word, exponential expressions. If you're using the 4 boxes, then everything in the big yellow circle needs to be written in box 1. If you're not doing boxes, doesn't really matter. You still have to write down everything in that big yellow circle. So that includes the starred notes, the definitions, everything with the arrows, all of that information. So please pause the video now to do that, because I think that'll probably take a few minutes. Okay, I'm just going to read what's on the screen. And official definition, exponential expression is an expression with exponents. It sounds like a silly definition, but that is it. Well, some of you may remember exponents from elementary school. And if you don't, or maybe your elementary school teacher didn't get to it, that's okay. We're going to start off our lesson talking about exponents and how to work with them. So an exponential expression will look like something like this. It says A, and then we read this to the B power. Now, A and B are numbers. This is just being very general for math. A is what is called the base. I like to remember it as the big bottom number. And it's the number that repeats. So a number, whatever it may be, a can be 2, 4, it could be negative, it could be a fraction, whatever it is, it's repeating. And it's being repeated multiplication. So it says connected by multiplication. B is in the top right corner. It's always going to be in the top right corner, and it's always going to be written a little bit smaller than whatever A is, or your base. B officially is called your exponent. I like to remember it as the extra small number in the corner. And it will tell you how many times the base, so big bottom number, repeats. Since this is a video, you can always pause it and go back if you need to. I am going to start to move on now to our first example. Now, if you are using boxes, we are going to be in box 2, and we actually have 5 questions we're going to fit into this box. There's not a lot of work for example 1, so that's why we're going to do 5 questions. Let's start right now with just the first 3, A, B, and C. And I want you to pause the video, write them down, and then unpause, and we'll go through it. Okay, so example 1, what we're going to do is practice how to write this repeated multiplication using exponents. It's repeated multiplication because I'm seeing in all 3, A, B, and C, there's a number being repeated, and it's being connected by multiplication dots. So we are not going to solve it. I don't care right now what 4 times 4 actually equals. I don't care what number it equals. I don't care what 5 times 5 equals. I don't care what 3 times 3 times 3 equals. We'll deal with that later. Right now, we're trying to make this look prettier because no one wants to just keep writing 4 times 4 times 4 times 4 or however many times we have to do it. I want a shortened way to write that problem. And that's what exponents helps us do. So the first thing we're going to do is figure out what the base is. What is the big bottom number? According to box 1, the big bottom number, or base, is what number is being repeated. So on part A, 4 is being repeated. So 4 is my big bottom number. I just write it like normal. I don't make it extra big, but just normal. To figure out my exponent, or extra small number in the corner, I figure out how many times did 4 repeat. So I just count up how many times it repeated. 1, 2. So 2 is our exponent. Now we do write the 2 a little bit smaller, and we write it in the top right corner of the number. This is our answer. We can read this as 4 squared, or 4 to the second power. Means the same thing, but this is now an exponential expression. B. You should try B right now. If you need to pause for a moment to do that, go ahead, but B, I want you to try on your own. Let's see how you did. What number is being repeated? It should be 5 is being repeated, so 5 is your base or big bottom number. How many times is 5 repeating? 1, 2. So you should have an exponent of 2. You read this as 5 squared or 5 to the second power. If you didn't already start to do C, you can do C now on your own. If you'd like to pause for a moment to try that, please do so. Checking your answer, you first ask what number is being repeated. 3 is being repeated. That means 3 is our base or big bottom number. How many times is 3 being repeated? 1, 2, 3 times. So that becomes the extra small number in the corner, or exponent. We read this as 3 cubed or 3 to the third power. It is the same thing the way you say it. We're not done under example 1, and in box 2 we have 2 more, because I want to show you that it can also be decimals and fractions that get repeated. So if you need to pause right now, please pause the video and write down D and E. These are the last 2 examples in this box. Okay, so a few things I want to point out to you. On D, we are multiplying by a decimal, and that decimal is in parentheses. It didn't have to be written in parentheses, but we do have parentheses around it to be clear that it's the entire decimal 0.1 that is being multiplied over and over and over again. So when I write my answer, I still want to be clear. It's a nice way to organize your work. So because I see parentheses in the problem, I'm going to keep parentheses in my problem. And the parentheses will still only go around the base or the big bottom number. So what is the big bottom number? What's being repeated? It's the decimal 0.1. So my parentheses right now are going around 0.1. When I draw my exponent or extra small number in the corner, it'll be on the outside of my parentheses. How many times does 0.1 repeat? 1, 2, 3, 4 times. So 4 is my exponent. It is not wrong if you write your answer like this, if you want to put parentheses around the entire thing. No, that is absolutely still correct. It just kind of looks a little bit weird, that's all. It's just not as pretty and it's not as clear that it's the decimal 0.1 to the fourth. If you write your parentheses around everything, again, it's still mathematically correct, but there is more room for error. Some people might look at it too fast and just assume it's 1 to the fourth and maybe ignore on accident the 0 and the decimal. So I'd prefer you not write it that way, but it is not wrong if you do. E, this time you have a fraction that's repeating. Well, it's okay to have a fraction that repeats. Notice there aren't parentheses on this one. You can also add your own parentheses if you want to, just to be extremely clear as what is the base, what is the big bottom number that's repeating. And with fractions, it might help. So I'm actually going to use parentheses around the base on this problem because what's repeating is the fraction 1/2. And I just want to be clear that the parentheses are kind of zooming in on it's this fraction, not just the number 1 is repeating, not just the number 2 is repeating, but the fraction 1/2 is repeated. How many times is it repeated? 1, 2, 3, 4, 5 times. You can read this as 1/2 to the 5th power. I should have circled the other one. Boop. Hopefully the idea of writing it isn't too bad. We are going to go to example 2 where we are going to rewrite, again, repeated multiplication using exponents. But we're also going to solve it. We're going to figure out what is the actual answer. So if you need to pause the video, if you need to finish writing, go ahead. Otherwise, we are going to move on now to example 2. If you're using boxes, this would be box 3. Now there's going to be a part C on this question, but I'm not going to scroll to it yet. Please pause the video right now to at least write down the whole directions on example 2 and A and B. Okay, so example 2, it says rewrite the expression using exponents and evaluate. So this is asking us to also solve the problem, solve the multiplication problem. Now, for most of you, it'll probably be easier to solve it first and then write your answer using exponents. If that doesn't, you want to write it as exponents first, that's fine. Remember that with multiplication, you can actually see multiplication using the dot, but sometimes you don't see the dot. So that's what we're going to see on example 2, is that we don't have the multiplication dot drawn for us, but it is secretly there. It is what's actually connecting the fractions 2/3 and 2/3. Remember, multiplication is like the glue that connects two numbers together, because when glue dries, it's invisible. It might help to draw in your multiplication dots in between all of the fractions on A and B, but you don't have to. It's just a good step just to remind you multiplication is there. Now I am going to solve this first, and then I'm going to write my answer using exponents. I'm choosing to solve it first. because it's easier for my brain to see multiplication of fractions than it is to look at the exponent and know what's going on. So when multiplying with fractions, you just multiply the top numbers and the bottoms. So 2 times 2 is 4, and 3 times 3 is 9. If you could simplify, you would, but I can't. So I have 4/9 as my evaluated answer, the solved answer. But I also need to write what was my original problem written as an exponent. So right next to the 4/9, I'm also going to draw another equal sign, and just like example 1, I'm going to ask what was being repeated. Well, it's the fraction 2/3. It is in parentheses, so I'm going to keep it in parentheses. 2/3 is being repeated, so that's the base. How many times did it get repeated? Twice. So 2 is my exponent. Both of these are my answer. The evaluated 4/9 and the exponential expression 2/3 squared. We're going to do it again on B. Of course, at this point, if you're feeling like you can work ahead, that's absolutely fine. Go ahead. Just make sure you're checking the answers. B, I'm going to do the same thing I did on A, and I'm going to solve first. Now I'm just going to need a little bit of space, because when you're multiplying with more than just 2 numbers, my recommendation is to group it. Group it 2 numbers together. So right now, I'm just going to work with these 2 fractions. Again, when multiplying with fractions, you multiply tops and bottoms. I notice this is negative, so I'm going to have to remember my rules with negatives. Right now, I'll just do normal multiplication. 2 times 2 is 4. 3 times 3 is 9. When multiplying 2 negatives makes a positive, so I keep 4/9, but I'm still not done with multiplication because I still have to multiply by my other fraction, negative 2/3. From here, it's still normal multiplication of tops and bottoms. 4 times 2 is 8. 9 times 3 is 27. How many negatives do I have now? Only 1. And if I have 1 negative in my problem, my answer stays negative. If you could simplify 8/27, you would, but you can't. So we leave it right there. But I do need to write what would my original problem be using exponents. So we ask what was being repeated. It's the fraction negative 2/3. It's in parentheses, so when I write my answer, it's going to stay in parentheses. How many times did negative 2/3 repeat? Repeated 3 times. So this is negative 2 to the 3rd. Both parts are my answer, the evaluated and the exponent. Now I did tell you that there's a part C on this question, and it's because I want to practice your decimals. So here's C. Still in box 3, we have to write this as an exponential expression, so something with an exponent, and we have to solve it. Just like A and B, I don't see the multiplication dot in between my decimals, so if it helps you to draw it in, go ahead, because multiplication is the glue in between. Now when I solve this, there's a lot of numbers here. I am going to group it together. I am going to group 2 numbers at once. So I'm going to figure out what negative 2 times negative 2.2 times negative 2.2 is. Now that's normal multiplication. For now, you ignore your decimals, you just line up your numbers. And keep on going with this. 2 times 2 is 4. 2 times 2 again is 4. Placeholder. 2 times 2 is 4. 2 times 2 is 4. Add. I'd have 4, 8, 4. Where do I put my decimal? Well, I look at my original problem. How many total numbers are after my dot? There's 1 here, 1 here. Gives me a total of 2. So I need 2 numbers after my decimal. So multiplication of 2.2 times 2.2 is 4.84. But I was dealing with negatives, so I need to remember my rules. When multiplying, 2 negatives make a positive. So I have a positive 4.84 times My other set of numbers I'm multiplying is the exact same multiplication problem. So I've already done that work. So I know it's going to be 4.84 again. Both positives, because again, on that second set of multiplication, we had two negatives, which make a positive. And I'm going to do multiplication here. Now this is a long multiplication question. Just to save some time, I did do all of the long multiplication for you. It does come out to be 23.4256. If you'd like to see the full work, I recommend you actually go look at the PDF solutions, because that's where I wrote it all out. Oops. But because of time in our class today, I'm not going to show that work. Trust me, it is the answer. I did check. But I'm not done. Once I do the evaluating, I need to write my original problem as an exponential expression. So we have to ask what was being multiplied. It was negative 2.2. It was in parentheses, so in my answer, I'm going to keep the parentheses. How many times did negative 2.2 repeat? 4 times. So together, that's my final answer. Again, if you need to pause the video to get caught up on any writing, do so. Otherwise, I'm going to move on. Example 3. This is box 4. Now, with this problem, I do want you to write down everything, including the actual example 3 and the question. Pause the video now to copy down everything in yellow. Okay, so example 3 is not related to writing our answers as exponents. This question is just, I've noticed, a lot of our problems, we have negatives, and when we have our fractions with negatives, sometimes our negative sign can be in different spots. And I just wanted to address this question. Does the location of a negative sign matter? What does it matter? I mean, in the answer, does it actually matter? So our first question, A, has the negative on the numerator. So it's negative 1 over 2 times negative 1 over 2. I know it's times again because there's a secret multiplication dot. On B, the multiplication symbol switched to the bottom, and it's positive 1 over negative 2 times positive 1 over negative 2. And C, the negative sign is in front of the fraction. What does that mean? It just means you do the negative of the fraction 1/2. Negative of the fraction 1/2. Now I want to know, does this affect our answer? If I actually multiply these fractions, does it matter if our answer, if your negative sign is on the top of your fraction, the bottom of the fraction, or in front of the fraction? So let's just do fraction multiplication. On the top, part A. Negative 1 times negative 1. Well, I'm dealing with fractions, so I multiply 1 times 1 first. Bottoms, 2 times 2 is 4. Now I'll deal with the negatives. How many negatives were originally in the problem? There were 2. Our rule is if there's 2 negatives, it makes a positive answer. So A becomes positive 1/4. Let's do B. B, again, multiplying with fractions. I'm going to draw on my multiplication dot so I don't forget that there's an invisible dot there. Multiply tops and bottoms, so numerators and denominators. Positive 1 times positive 1 is positive 1 over negative 2 times negative 2. Treat it like normal multiplication. 2 times 2 is 4. Then go back and deal with your negatives. How many negatives are there? There are 2. And 2 negatives make a positive. So again, I get a positive 1/4 answer. Let's look at our third option for where the our negative sign could be. Right now, I'm just going to ignore the negatives and just do normal multiplication of fractions, which means tops and bottoms. So 1 times 1 is 1. 2 times 2 is 4. How many negatives were in the problem in general? There was 2. Even though they were in front, overall we had 2 negatives. And our rule is, there's 2 negatives, your answer is positive. So what do you notice about these answers? Hopefully you say that they're the same. So going back to our question, does the location of a negative sign matter? answer is no. So your negative signs can be written on the top of your fraction, it can be written on the bottom of your fraction, or it can be written in the middle of the fraction, like in front. I personally tend to write my negatives on the numerators. Why, I don't know, it probably is just habit. I find it easier just to keep it on the numerator than I do to keep it on the denominator. When you write the negative sign in front, in the end, it really applies to just one number. So if it only applies to one number, you might as well tag it in on the top or the bottom. But it doesn't affect your answer in any way. We are almost done. I know this is kind of a long lesson. I just want to practice one more thing with our exponents. And this would be the first time that we have to go to the back of your piece of paper if you're using boxes, because we're going to be in box 5. If you're not using boxes, it's fine, but this is our last example now, and it's a chart. So write down example 4, and you'll actually need to copy the chart exactly how I have it. Expanded form, so like the middle of your chart needs to be the largest part of your chart, so make sure you leave a lot of room there. Pause the video and copy it down. Okay. This is the last question, and there's a reason I've chosen to do a chart one more time dealing with our exponents, and I'll kind of point that out at the end. We have 4 questions, and then the middle of our chart says expanded form, and then it says positive versus negative. So that would be if your answer, if I actually multiply things out, is our answer positive or negative? Expanded form means repeated, and I'm not going to write out the word multiplication, I'm going to use the dot. Repeated multiplication. So we've practiced during this lesson how to start with repeated multiplication and write the exponent. I just want to go backwards, starting with something with an exponent and trying to write it out. So -4 squared. Well, -4 is our base. It's the big bottom number. And according to our very beginning, box 1, big bottom numbers or bases is what repeats. Your exponent, or extra small number in the corner, in this case 2, tells you how many times does it repeat. So to write out -4 squared, I'm going to keep it in parentheses. This means that -4 gets repeated with multiplication 2 times. So I have -4 times -4. When it asks you, is your answer positive or negative, I don't care what the number is. I just want you to practice thinking about your negative multiplication rules. How many negatives are in this problem? 1, 2. And our rule is if there's 2 negatives, it makes a positive answer. If you want to abbreviate positive as P or write out POS, that's fine. I'll just write the whole word for now. Let's do it again for our next one. -3 to the 5th power. What is being repeated? What is your base? Well, that's -3. So -3 is being repeated how many times? According to the exponent, 5 times. So I write out -3 times -3 times -3 times -3 times -3. You should have a total of 5 of them written. 1, 2, 3, 4, 5. Yep, that's good. Now, how do I know right now if my answer is positive or negative? Well, let's use our rules. Now, when you're dealing with multiplication of multiple numbers, again, my recommendation is just to group. So I'm going to draw these little brackets, and I'm going to group 2 numbers together at a time. My first 2 numbers, -3 times -3, applying our rule, 2 negatives make a positive. And I'm going to write some little stuff out in just a minute. So I have a P for positive times. My next set of multiplication, again, was -3 times -3. How many negatives were in that set? 2. 2 negatives make a positive. Times what was left over. We had a -3. So right now I had a positive number times a positive number times a negative. If I grouped again, and I'm going to use my abbreviation over here, P and P for positive and positive, Well, two positives when multiplied together give me a positive answer, times what's left over is a negative. So if I have a positive and a negative, according to our rules, it would give me a negative answer. Maybe you don't like that. Maybe you don't trust that without seeing the numbers. So let me just prove, don't look at that. Maybe I just prove this to you. If my first two groups together, -3 times -3, that came out to be a positive 9 times. That was my first letter P. My second set of groupings was again -3 times -3. When multiplying, two negatives make a positive, and 3 times 3 is 9. Again, another positive. Times what was left over, -3. Multiplying even more. I again keep grouping two numbers together. So positive 9 times positive 9 is positive 81 times what's left over, -3. From here, you would just do your normal multiplication. 81 times 3 is 243. How many negatives are in the problem? One negative, which would have made my answer negative. So when I use the letters up top, I just kind of proved that my answer was negative to you. Keep going, last ones. 2 to the 4th, writing that out. This would be what's repeated? The base positive 2. How many times? 4 times. So we'd have 2 times 2 times 2 times 2. What do you think the answer is going to be? Hopefully you say positive, because these are all positive numbers. Your last one, -0.01 to the 6th power. What is being repeated? It's the base, so -0.01 repeats. How many times? 6 times. I recommend you write kind of small, because that's a lot to fill in. So you have 0.01 times -0.01 times -0.01 times -0.01 times -0.01 times -0.01. I should have 6. 1, 2, 3, 4, 5, 6. Okay, now we need to decide if this answer is positive or negative. If I group together, I don't even care what the numbers are. Group two numbers together at once. So I can actually have a perfect pairing. I have 3 pairings here. In the first pairing, a negative times a negative, even though they're decimals, 2 negatives make a positive. Times, by next set of pairings, again, 2 negatives make a positive. Times, my third set in this case, 2 negatives again make a positive. So I'd have all positive numbers in the end being multiplied together, which gives me a positive answer. Now, I want to know, do you think there's a relationship between the exponents and whether our answer is positive or negative? So if you look at a moment at all these exponents, it doesn't matter what the bases were, look at the exponents. On the top, on the first one, we had an even exponent. Okay, that gave me a positive answer. Let's see, on my second one, I had an odd exponent, and that gave me a negative answer. Okay, this third one, I had an even exponent again, and that gave me a positive exponent, or positive answer. I think I might see a pattern. My last one, a positive exponent, gave me a positive answer. Well, there is actually a relationship, and I do want you to write this down. Doesn't matter what your base is. If you have an odd exponent, your answer is negative. If you have an even exponent, your answer is positive. If you don't trust it, multiply it out, and you'll get that same answer no matter what. So make sure you write down this information, and then that is it for your lesson. After this, you should just start working on your lesson 9 homework. That's brand new for today. If you finish that, work on lesson 8 from yesterday. If everything is done, move on to Dreambox. I'll see you guys tomorrow.